Welcome back to this online tutorial. We had covered item 16. Now we proceed with item 17. What does item 17 say? Item 17 says that during a routine air quality assessment near a fuel storage depot, environmental scientists collected a sample of unknown gaseous hydrocarbon X suspected to be linking from, so they collected a sample of unknown gaseous hydrocarbon X suspected to be linking from underground pipelines. What do we have? So hydrocarbon, remember, is made up of carbon and hydrogen. In the laboratory, elemental analysis of the gas showed that sample X contained 7.2 grams of carbon. We have mass of carbon, and 1.6 grams of hydrogen. We also have mass of hydrogen. So we have mass of carbon and that of hydrogen. So to further identify the gas, the scientists measured its density under standard conditions and found out that 2.56 decimeters cubed. Now this information is very important. 2.56 decimeters cubed of hydrocarbon had a mass of 5.028 grams. This information is going to help us determine molecular mass. Using this information, the scientists set out to determine the molecular formula of the hydrocarbon in order to assess its potential impact and safety risks associated with the link. So we want the molecular formula of the hydrocarbon, item 17. Hope you've taken note. This information, 7.2 grams of carbon and 1.6 grams of hydrogen, this is going to help us determine empirical formula. Then 2.56 decimeters cubed occupy 5.028 grams. This will help us determine molecular mass, which we shall use in finding molecular formula, just as we have seen in the previous items. As a result, therefore, we have the following. For item 17. Item 17, this is the response to item 17. So the elements present are carbon and hydrogen. I have identified them. Then composition, carbon is 7.2 and hydrogen is 1.6. Next, we determine number of moles. To determine number of moles, we divide each of the masses by the relative atomic masses of the elements. Relative atomic mass of carbon is 12. RAM of carbon is 12 and that of hydrogen is 1. This information may not necessarily be attached directly to the question, but you check the front page of the question paper. That information is always there. So we divide. For carbon, we shall have 7.2 over 12. For hydrogen, 1.6 over 1. And we obtain this as our moles. Next, we determine the simplest mole ratio. What do you do to determine the simplest mole ratio? You look at these two calculated moles, then you divide by the smallest of them. So if we have 0.6, if we have 0.6 and 1.6, the smallest is 0.6. So we divide both of them by 0.6. So we shall have 0.6 over 0.6, 1.6 over 0.6. And calculating here, we obtain 2.667. Now, this is very important. You shouldn't rush. Now, some learners will rush and round off this 2.66 to 3. That is wrong, very wrong. If you have 0.667, you don't round off to 3. I have already summarized this information. I have summarized this information for you to understand. And I hope that by now you have it. Let me take you back. You should note the following. I will remind you that if digits, the first bullet was saying that if these ratios 1.1, if you have 0.1, 0.2, 0.7, 0.8, 0.9, anything 0.1, 0.2, 0.3, 0.8, 0.9, you can round off. But anything with 0.33, 0.5, 0.6, now this is the case where we are. 2.667, 0.4, we are here. What do you do? It says that if they appear if they appear in the calculated ratio, the calculated ratio should be multiplied by, for 0.33, you multiply by 3. 0.5, you multiply by 2. 0.667, you multiply by 3. Now, this is where we are. 0.4, you multiply by 2. Now, we are on 0.66, you multiply by 3. Therefore, going back to my item, we shall have the following. So I multiply throughout by 3. If 3 multiplies with a 1, I get a 3. If it multiplies with 2.667, I get 8. As a result, the empirical formula will be C3H8. This is the empirical formula. This is the empirical formula. Now I proceed to molecular formula. To determine molecular formula, we use empirical formula times 10 equals empirical formula times N. Empirical formula times N equals molecular mass, but we don't have molecular mass. However, we don't have molecular mass, but we have a hint which has been given that we can use to find molecular mass. So that hint says that, it says that 2.56 decimeters cubed occupy 5.028 grams of X. This is what is given. So if 2.56 decimeters cubed occupy, so we want molecular mass. That's why mass is on the right-hand side. If this volume occupies that mass, what of 1 decimeter cubed? 1 decimeter cubed will occupy 5.028 over 2.56 grams. What of the standard? Now you may ask me why the standard now. The standard represents 1 mole, and 1 mole is molecular mass. The standard will occupy 5.028 over 2.56 times 22.4, and calculating this will obtain 43.995, which is approximately equal to 44 grams. Alternatively, another learner will come and use the following approach. He will come and say, you've told me that 2.56 decimeters cubed are equal to 5.028 grams. This is what you've informed me. So if I want to determine molecular mass and I have a volume, I know what the standard volume is. The standard volume may not be directly attached to the question, but it may be on the front page of the question paper. And that standard volume, it is 22.4 decimeters cubed. Now, that learner will ask him or herself, if 2.56 occupy this mass, what of 22.4 will occupy which grams? Then you will cross multiply. We shall have 22.4 times 5.028. We multiply these two, then divide by 2.56. We have seen already such conversions. So molecular mass will be 5.028 times 22.4 over 2.6, and this is equal to 44 grams. Now this is my molecular mass. Then I take it back. We substitute in empirical formula times N equals molecular mass. I substitute my empirical formula, which is this, then equate to 44. Then carbon is 12, hydrogen is 1. I substitute them here. So we shall have 12 times 3 plus 1 times 8. This information you are seeing 12. These are the relative atomic masses of carbon. This information is always given that capital C is 12, capital H is 1. So that's why I have 12 times 3, because there are 3 of them, and 1 times 8, there are 8 of them. And this is equal to 44. Now summing here, we shall have 44n equals 44. 44n equals 44, dividing both sides by 44, we obtain n equals 1. And substituting the value of n back, if we put it back, we shall have our empirical formula times 1, and 1 does not change anything. So therefore, this will be our molecular formula. This is item 17. As for now, allow me first stop here. Then we shall look at the next items. We shall look at the next items. We shall look at the next items in the